this video is going to cover recursive definitions. Now, recursive definitions can apply to either arithmetic or geometric sequences. There are ways to actually have it apply to sequences that are non-arithmetic or geometric, but they can get pretty wacky looking. So we're going to stick with pretty much the arithmetic or geometric ones. So what is recursive definition? It is a two-part definition of any arithmetic or geometric sequence in terms of u sub n minus 1. So remember, u sub n minus 1 is that previous term to the nth term. So if you had a sequence that had 10 numbers in it, u sub n would probably be considered the 10th term, the last number. And then u sub n minus 1 would be the term directly previous to it, or the 9th term in that sequence. All right, so recursive definition looks a little strange. Let's get a little practice with it. All right, write the recursive definition for the sequence. So there are certain things that are always going to be the same. U sub n is equal to, now what I want to look at is what's going on from term to term here. So how am I getting from negative 10 to negative 12, and then negative 12 to negative 14, negative 14 to negative 16? And in this case, I'm kind of thinking like I should be adding a negative 2, and then adding a negative 2, and then adding a negative 2. Okay? So if that's what I'm doing, then to get any term in the sequence, I need to take the previous term, so u sub n minus 1, and I need to add a negative 2. All right? But this this is the first part. Remember I said it's a two-part sequence, or I'm sorry, two-part definition. So the second part is where n is greater than or equal to 2, and, little and symbol here, and u sub 1 is equal to, in this particular definition, u sub 1 is equal to negative 10. So this whole thing, Miss Kern writes really large, this whole thing is the recursive definition for that sequence. All right. So again, how does it look? It's the any term in the sequence is the previous term being added to a negative 2. All right, so take your previous term, add negative 2, and you're going to get the next term in the sequence. Second part, where n is greater than or equal to 2, and u sub 1 is equal to negative 10. So why do you have to have n is greater than or equal to 2? Because you can't have a one-number sequence. All right, n is the number of terms in your sequence, and you need to have at least 2 terms to talk about a sequence. You cannot talk about it in terms of just one. All right, one number does not make a sequence. All right, let's look at the second one here, right? The recursive definition. So we've got 3, we've got 6, we've got 12, we've got 24, and I'm thinking to get from term to term, I am multiplying by 2 each time. Let me do a quick double check there, make sure I'm not doing anything goofy. Double with 3 is 6, 6 times 2 is 12. Yeah, okay. So recursive definition, you always start with u sub n is equal to. Now, mathematically, you can do this one of 2 ways. I'm going to say that it's 2 times u sub n minus 1, simply because my brain has told me for years I need to put the number in front. All right? And that's the first part. All right, second part, where n is greater than or equal to 2. That's never going to change, okay? And u sub 1 is equal to 3. There is your recursive definition. Okay, so let's keep doing the same thing. If we look at the next couple of problems here, we've got negative 1, positive 3, positive 3, negative 9, negative 9, 27. All right. So So in order to get from a negative to a positive, I needed to have, well, in this case I already know I'm multiplying because I'm going to keep alternating signs here. So I need to have multiplied by negative 3. So negative 3 times 3 is negative 9. Negative 9 times negative 3 is positive 27. All right, so this is a multiplier of negative 3. So recursive definition, u sub n is equal to negative 3 times the previous term, all right, where n is greater than or equal to 2. The number of terms in the sequence has to be 2 or more, and the first term in the sequence, u sub 1, is equal to negative 1. We need to define where this sequence starts. So that's why you have to put in there the u sub 1 is equal to, whatever it is. All right. Last little example here for the recursives. Let's see, we're starting with 0, then we've got negative 1, negative 2, negative 3. So what we're going to be looking at here is we are adding negative 1 each time. Okay? So to get any term in the sequence, I want to take the last term, I'm going to add negative 1 to it, where n is greater than or equal to 2, and u sub 1 is equal to 0. And that's your recursive definition. A couple examples. All right. So we've got those problems where you take a sequence and you can write the recursive definition. The next two examples give the recursive definition, and you need to write some numbers in, or some terms in the sequence. So I want 5 terms, all right, given by this recursive. So I already know the first term. It's right here. It's 1/3. All right, so let's use set builder notation here, 1/3. And this definition is telling me that I need to take my previous term and multiply it times 6. So if I take 1/3 and I multiply times 6, I'm going to get 2. If I multiply times 6 again, I'm going to get 12. Multiply times 6 again is 72. I need 1, 2, 3. I need one more term. So 432. I'm going to close off that set. All right. So that should be the first 5 terms of that sequence. Okay. So that one's all done. Let's take a look at the next example. I want the same 5 terms. Okay. In this case, I'm starting with u sub 1 is 14. And to get any particular term in the sequence, I'm going to take the previous term and I'm going to subtract 4. So I've got 14 minus 4 is 10. 10 minus 4 is 6. 6 minus 4 is 2. And 2 minus 4 would be negative 2. 1, 2, 3, 4. That is all of the terms that I need. So that particular problem is done. Okay. So a couple of quick problems. We've got 4 little problems here to end. In the problem below, a sequence and a recursive definition are given. Fill in the blanks. All right. So we've got a sequence here. It goes 20, 10, 5. So to get from 20 to 10, you can either chop it in half or subtract 10. But then to get from 10 to 5, you can't subtract 10. You can only chop it in half. So this is going to be multiplied by 1/2 each time. All right. And if that's the case, then 5 times 1/2 would be 5/2. Let's see. A couple things to fill in on the recursive definition. We've got the term in the sequence. What are we doing to the previous term? Well, we're going to multiply it times 1/2. N is greater than or equal to 2, and u sub 1 is equal to 20. Make sure you fill in all the blank spots. All right, so let's see what we've got here for part B. It looks like we've got 23, a blank spot, 19, 17. I'm kind of thinking I'm going to be adding a negative 2. So that would be 21 there. I just said I was adding negative 2, where n is greater than or equal to 2, and u sub 1 is equal to 23. All All right, I like this so far. Two more little problems here, and this note sheet will be done. So a movie theater has 14 seats in the first row. So U sub 1 is equal to 14. Each row after it has 4 more seats, so that's going to be, let's say, plus 4. Write the recursive definition for the sequence of seats. All right. So U sub n would be whatever row of the movie theater we're talking about is equal to the previous row plus 4, where n is greater than or equal to 2, and U sub 1 is equal to, what was that number in the first row? 14 seats? Wow, that's a horrible 4. All right, much better. All right, so there is the recursive definition that will tell you any particular row based on the row prior to it. Okay, and last one. A single sheet of paper is folded in 2 sections. It's folded again to give 4 sections. The third fold give 8 sections, fourth is 16. All right, so recursive definition for the sequence. So if you start with a single sheet of paper, you have 1 section. All right. Each time that you fold it, you are multiplying that section by 2. So you have 1 section, then 2, then 4, then 8, 16, and so on. So write the recursive definition for the sequence of folds. So any given set of folds here, all right, would be, or sections, I should say. Yeah, sections. So it's going to be 2 times the previous number of sections, right, where n is greater than or equal to 2, and U sub 1 is equal to 1. Because, again, a piece of paper starts off as a single piece of paper. It hasn't been folded at all. So there's just 1 section that makes up the whole thing. All right, so that was recursive definitions. Hopefully this helps with some of your practice problems. As always, send me any questions that you have about the material.